So bond J is a 3% coupon bond. Bond K is a 9% coupon bond. Both bonds have 15 years to maturity, make semi-annual payments, and have a yield to maturity of 6%. If interest rates suddenly rise by 2%, what is the percentage price of these bonds? What if the rate suddenly falls by 2% instead? What does this problem tell you about the interest rate of lower risk coupon bonds? So let's just set them up and determine what they are currently worth at the present value right now. So we have bond J, and we have bond K. Now they both have semi-annual payments, so both of their PY and CY is equal to 2. Our payments per year and our compounding periods per year are equal to 2. They both have 15 years to maturity, so that means with 2 payments per year and 15 years to maturity, they both have an N of 30. They both have currently interest rates, market rates of 6%. We'll solve for their present value at the end. Their payments are a little different. J is a 3% coupon. So what we'll do is we will just call this a face value of $1,000 for both of them. It just makes it nice and easy for us. So 3% coupon on $1,000 is $30 per year. Semi-annual payments means we divide that 30 by 2, which we get $15. We can just put 3% here and 9%, just so you can see the difference. And 9% is $90 per year, divided by 2 is 45. Our future value for both of them will be the same face value. It'll be $1,000. So what we need to do is determine the present value for both of them. So we'll start with bond J. Second, PY, CY is 2, 30N, 6IY, payment of $15, $1,000 future value, compute present value, and we get $705.99. And the only difference that we got to change over here is this payment to 45. Compute present value, and we get $1,294.01. So this makes sense. It's 6% market rate. 3% bond, you need to provide a discount, so that's why it's worth less than $1,000. 9% of bond is above market rate, so you get a premium, which is why it's $294 above market rate. And look at the difference. This is $1,000 minus $294.01. This is $1,000 plus $294.01. Right? So that makes sense because they're equally the same distance apart from the market rate of 6. But what happens if the rates suddenly fall by 2%? So now, what we'll do is a present value. So this is a minus 2%. This is a plus 2%. And that 2% is based on the market rate. So this actually becomes a 4, and this becomes 8, 4, 8, and we can solve for the present value. So what we need to do here is we're not going to change anything. We'll put our payment back to 15, and we will now make this market rate 4%, so 4 IY, and we compute our present value. And we get 8888.02. And here we'll now make the market rate 8%, compute our present value, and we get $567.70. So we'll do the same thing over here. This one we will change our payments back to 45. Go 4%, compute our present value. We get 1559.91. And we'll do the same thing with 8%, 8 IY, compute our present value, and we get 1,086.46. So what does this mean? Well, we need to determine the percentage price change of these bonds. So we'll start here, 8888.02 divided by 705.99. Minus 1 is 25.78%, which is a plus. That went up 25% from the last one. And 567 minus 7 divided by 705.99 minus 1 is 19.59%. It went down 19%. So what happens over here? We see 1559.91 divided by 1294.01 minus 1. We went up 20.54%. And here, 1086.46 divided by 1294 minus 1. We got 16.04%. So what do we see? So the exact same changes to market rate. Everything's the same other than the payment amount, the coupon rate. But here when the market rate went down, this went up by 25%. This only went up by 20%. And here when the market rate went up, this went down by 19.5%. This went down by 16%. So what does that mean? It tells you that the lower the coupon rate, the higher risk, interest rate risk there is for your company. And so this would also be the same. Let's say that the payments were the same, but this N was longer. It was a longer bond. The more time, the more likelihood that this change will be more affected by the market rate as well. So time and a payment amount will affect the interest rate risk.